Okay, good afternoon. My name is Rich Boukal. I'm the Director of Global Sourcing for Mitsubishi Power Systems. Kind of like to talk about three items today. I'd like to give you a brief history of what Mitsubishi is and Mitsubishi Power Systems America is in the United States and Canada, and then talk about some of our logistic issues we've had in the past, and then what do we need in the future? What are we going to be doing in the future, and what kind of suppliers we're going to need as we go forward. On an overview, I'm going to talk more about the Mitsubishi Group. Our Lake Mary headquarters office is in Lake Mary, Florida. Our wind turbine office, which is located in Newport Beach, California. Our Fort Smith, Arkansas nacelle assembly factory that's going to be supporting our wind turbine division. Our Orlando Service Center, which supports our gas turbines and steam turbine energy. And the Savannah Machine Works facility that is the head of our installation and assembly of gas turbines. Mitsubishi Group is made up of over 40 companies. Each company is a separate entity and operates independently. Most people, when I say I'm from Mitsubishi, they think I sell automobiles or TVs. We're a whole separate division. We're part of what they call Mitsubishi Heavy Industries. Mitsubishi Power Systems was developed in 2001. It is the largest division of that industry. Now, what does Mitsubishi Heavy Industry provide? They provide everything from shipbuilding, air transportation, bridges, air conditioning units, printing machines, generators, and of course power energy facilities such as combined cycle and related commodities. This is a brief map kind of giving an overview of where we're at in the United States for the different divisions. You see our Lake Mary headquarters is in Florida. We have a service center in Florida. We have a Savannah Machine Works operation that's currently in phase 3 construction. Our Arkansas wind turbine facility, which is in construction, and our Newport Beach, LA office, which handles our wind turbine and SCR group. It's just a photograph of our headquarters in Lake Mary. This is where our president sits, responsible for all new type of power generation in the United States and Canada. So anything what we classify as a greenfield project, which is built from the ground up, is handled out of this office. We currently have 150 employees, and we were established in the year 2001. This is a photograph of an overview of a typical power plant that we're involved in. You can see each stack there, that's a power island, and each one of those has a gas turbine and auxiliary equipment associated with it. This is down in West County, Florida by West Palm Beach. There's a total of 9 units down there. This is during the construction phase where you see the 6 stacks, so the 6 gas turbines actually been delivered down there for that particular site. Our wind turbine office in Newport Beach, California handles the wind turbine supply and logistics. There's 3 components of the wind turbine. There's the blades that we have a joint venture with a company in Mexico called Ventec that's 50-50 owned by MHI. The towers, which we source from U.S. suppliers and have to be sent to remote locations. And then the nacelles, which is the gearbox, which is part of what we're going to start sourcing from the United States. Here's a brief map, gives you an idea exactly where the locations are. And logistics, again, is a very important phase of this because they're in such remote locations in Texas and California, of course, where the wind blows. So that's where they're going to put them at those locations. And they're very hard to get to. Even telephone service is very difficult at those locations. This is an artist caricature of our new Fort Smith, Arkansas facility. We've started construction on the year 2010. It'll be finished in 2011 in October. It's going to be fabricating the nacelles, which is the gearboxes of the wind turbines. There's going to be a lot of logistics in and out of that facility. It's going to be 300 people capacity with doing about 250 units. Now, as those units right now are all sourced out of Japan, the idea is to get 80% of these sourced out of the United States. So again, MHI is bringing jobs back to the United States as opposed to shipping them out of the United States. Our service facility in South Orlando currently employs about 580 people. They do all the service work, what we call long-term service agreements, LTSAs, and also outage work for power plants. So they're involved in making sure they can work on our equipment as well as Alstom, Siemens, GE's, everybody's equipment in the marketplace, in the energy market. This is our crown jewel, the Savannah Machine Works facility that's in phase 3 construction. Phase 1 was completed in 2000, phase 2 in 2010, phase 2 in 2011. At the completion, it's going to be turning out about 12 gas turbines a year for the North America market. So there's going to be a lot of logistics of material coming in from the port as well as going out. Yeah, the groundbreaking ceremony happened on September 21st, 2009. Mitsubishi, again, sending jobs to the United States. Considerable investment opportunity there for Mitsubishi in the United States to produce gas turbines. This is going to be the only place outside of Japan making gas turbines for Mitsubishi. Now, what is Savannah Machine Works going to provide? Basically, there's three components: the turbine assembly, which is in the top right-hand corner, the rotor inspection and repair, which can have a turning pit, and a gas turbine combustor parts, which are going to be supplied for us as well as others gas turbines. Now, in global sourcing logistics, what's the responsibility? Well, we have the total logistic responsibility for ocean freight, import-export compliance, port operation, all U.S. inland transportation, wherever the remote destination is, wherever the power plant is going to be built. Also, complete supply chain management. What I mean by that is suppliers that we buy from, also they have to ship to the final destination. They manage that. So our logistics group that I'm responsible for has the establishment of the entire inland transportation supply chain in the United States, covering the entire North American market. That's Canada and United States. In that regard, we use rail, barge, truck, and heavy haul type of transportations to get the item to the final destination. Some of the commodities we currently go out and subcontract are freight forwarding, customs broker, rail surveys, clearances, route surveys, trucking, both bulk and heavy haul, marine surveyors, and any port tie-down and stevedoring done at the port. This is a photograph of a typical gas turbine that's arriving at the port. This, again, was the West County project down in Florida, West Palm. But you can see it's a 360 megawatt, 720,000 pound gas turbine that's being taken off of the ship and put on actually, this was shipped by over the road, so it was put on a tractor trailer. This is the tractor trailer it was put on. It was the largest move ever done in the state of Florida for weight-wise, and we did have a lot of help from the Florida Department of Transportation on that. It's a 285-inch length, 22-foot wide trailer. The capacity of this trailer is 500 tons. You can see it's got 16 axles, 128 tire trailer. Combined with our gas turbine, the weight was 1.24 million pounds. Now, again, we shipped 9 of these, going from the port to the final destination about 30 miles away. All kinds of obstructions. We had to move wires. We had to reinforce bridges. But again, it was logistics that we had to provide in order to get it to our final customer, which was FPL. This is a project a little bit closer to where we're at present time. This is for Georgia Power. This is a gas turbine loading by folding crane onto a shiftable rail car. This was shipped on the CSX line from Charleston to the final destination just outside in Smyrna, Georgia here. We had 6 of these gas turbines go, and as you can tell, it's on a shiftable car, so it can go laterally 12 inches to 18 inches, and it can also go horizontal and vertical, so you can put it down whenever you have an obstruction. Just a few photographs. These are auxiliary cargoes. So we do have flatbeds, and we do have also just truck cargo have to go out. These are arrived by ship from Japan. These have to be transported also to the final destination, so all that logistics has to be taken care of by our office. Mitsubishi did look ahead and decided we wanted to purchase 2 rail cars, shiftable. So we actually fabricated 2 rail cars to shift our gas turbines as they meet obstructions. These were, this photo here is for the Georgia Power project. It was at the Charleston port. The right photo shows the gas turbine on the dock at the Charleston port. The below photo shows it going around the curve of the Charleston port. We have 2 of these cars. They're a 20-axle depress center, 450-ton capacity, 40-foot length with a 14-inch lateral shift from left to right when we find an obstruction. Just another photograph of the rail car that we have. We have 2 of these. One of them we keep them up in Pittsburgh, Pennsylvania area where we store them. This is a good picture because you can kind of see when you come to an obstruction what it has to do in order to shift. With the size of our gas turbine, there's going to be times where the railway is going to want to give us clearance unless we can shift it left to right to go through an obstruction. This demonstrates the shifting of the overhead bridge to avoid that, as well as the side bridge. Once it gets to the job site, it gets unloaded by a gantry crane. This is an example of it gets sent directly off of the rail car, gets put on the gantry crane, goes to the final foundations, and gets put on the foundations and gets tied down. One of the things we also are providing support on, and what we're going to need subcontractors to do for us, is the tie downs. This is an example of we have engineered drawings which we tie down our gas turbines to either the rail car or the truck, depending on what's required at the time. Key future projects we have are for the, we have 2 in Canada. One's called the NMAX, one's called Trans-Canada. Total of 5 gas turbines. We just were awarded 3 for Virginia, for Dominion. So we have all kinds of opportunities for logistics in the future. One of the keynotes with our sub-suppliers we look for is understanding railway and heavy haul operations, understanding the details of equipment drawings, because we have drawings of our gas turbine that have to be provided, as well as the planning process. When we sell a gas turbine, it takes 3 to 5 years before it's actually shipped. A lot of things change, a lot of plans change, a lot of obstructions come up, a lot of rails get diverted. So it's starting early and always expect delays.